Well, let's break this down a little bit. So ERW, enhanced rock weathering, explain it to me.
If we look back at geologic time on a global basis, what you can see is, like, if you look at a graph of atmospheric CO2, rock weathering has been one of the primary drivers at pulling CO2 down from the atmosphere. Basically just means when it rains on these silicate rocks, they weather, so they dissolve. It generates something called alkalinity, which pulls CO2 out of the atmosphere into the water, and that water flows down streams, rivers, into the oceans. You can see this natural effect when you look back at the CO2 levels. You see things like when the Himalayas, for instance, form and those silicate rocks are exposed to the atmosphere, we then see the exact drawdown of CO2 from the atmosphere that corresponds with those same times that those mountains formed.
Huh. Okay. That's a fact I did not know until today.
Rock weathering over a long geologic time will help draw CO2 down, but not on speeds that are relevant to, humans. And so our question is, what if we could speed that natural process up? And that's what enhanced rock weathering is. It's taking that same rock weathering process and trying to speed it up. It turns out that the simplest one might actually be the most effective. And that's to take those same rocks that we already have and just crush them up to increase their reaction surface area, and then take them and spread them in areas that are high in CO2, like cropland, to increase that reaction rate. And all of a sudden you can go from removing carbon over, say, geologic time to really human timescales, just a couple years.
My reading of technological history is like many things that end up scaling are deceptively simple.